Welcome back. In this video, I'm going to explore the area of circles, sectors, and segments. So, as a matter of review, remember or recall that the formula for the area of a circle is pi times radius squared. And of course, we will give this in square units or units squared. Also, prior knowledge, we know that the measure of the central angle of a circle equals the measure of its intercepted arc. So if we have circle C here, if we know that angle ACB equals 45, then we also know that arc AB also measures 45 degrees. And we should know that 45 degrees is, in this case, it's 360 degrees around the circle. So in this case, 45 out of 360 is 1/8 of the way around the circle. So that concept of a percentage or a portion of the whole circle is going to be important for us. Some definitions. A sector. A sector of a circle is the region bounded by two radii and an arc of the circle. So we again could have sector ACB. So our sector is the blue shaded area here. So think of a piece of traditionally cut pizza or grandma's apple pie from Thanksgiving. Okay, a piece of the pie or a piece of pizza is a sector. And we find the area of the sector by finding the area of the circle and then using that fraction of the circle. So in this case, we have to have our arc. We have to know what our measure of our arc is. So in this case, the area of our sector is 60 out of 360, or 1/6 of the whole circle, and the area of the whole circle would be radius squared pi. So we're looking at 1/6 of 12 squared pi. Now be careful, follow your order of operations here. We have to take 12 squared before multiplying by 1/6. Don't multiply the 12 by 1/6 and then square it. So it's 1/6 of 144 pi. And our answer here is 24 pi units squared. So that is the area of our sector. Next is a segment. The segment of a circle is the region bounded by a chord and its corresponding arc. So if we have chord AB and we have arc AB, the area of the sector is that region shaded in red. Now to find the area of the sector, that's a little tricky. There's some information we need. We will need a variety of things. We will need the arc measure, or that is degrees, remember that. And we will need the radius of the circle. So to find the segment, the area of the segment is equal to the area of the whole sector minus the area of this white triangle. So we've got a little work to do, but the the segment is the area of the whole sector. We find the area of the whole sector and then pull out this triangle. So let's see if I've got enough information to do that. The area of the sector minus the area of the triangle. So the area of the sector, since we've got a right angle here, we know that our arc is 90 degrees, so we've got 1/4 of the circle. So we have 1/4 of our radius is 6. Call it circle O. Our radius is 6, so 1/4 of 6 squared pi. That'd be the whole sector. So 1/4 of 36 pi, or 9 pi. Minus the area of the triangle. Well, fortunately, this is a right triangle. The easiest triangle to get the area of is a right triangle, because my radii here are both 6. They're congruent. Those are the legs of my triangle. So minus 1/2 base times height, or minus 1/2 of 36, which is 18. So 9 pi minus 18 units squared. And since we know pi is a little more than 3, 9 times a little more 3, 27, plus a little more, 28, 28.5. This makes sense. 28 minus 18, that's about 10 units. Okay, but our exact answer, 9 pi minus 18 units squared, that would be our final answer. So that's how we find the area of a segment. So with that, you're in good shape to be able to find area of sectors and segments, and we'll work on problems like this and ones with even substantially greater challenge when I see you in class.